Hello and welcome to this latest edition of the podcast. My name is Javier Solsona and I'll be showing you a way to attach an object to the camera so that we can lock the object and it doesn't move in our screen. We did a quick counter here, so we are just attaching it. Wherever we move the camera, the counter doesn't move. On top of that, we can still also change the focal length and the counter doesn't move. So we're going to walk through. This is a simple setup of how to get this done. We're going to start with a cube to get a feel of how this is set up. Since we're going to be attaching our setup to a camera, we'll be doing two perspective cameras. So we're just going to be showing all the cameras. So it's going to be easier to identify with them. We can see them. We're going to be attaching here to this camera. So if we move it, we'll see that the camera moves in the top view. So the way that we do this, it's we're going to be building a couple of groups right above the cube, so that we can add a few constraints. We're actually going to be scaling this object. Especially when it comes to the focal length. If we want to lock just the object here to the camera, we go to outliner. We can just pretty much simple as just parenting the cube to the perspective camera. We can see that now when we move that the cube doesn't move, and we're kind of half the way there. The problem comes when we select our camera and we change the focal length. We can see that that object is not actually staying still. And this is a problem, especially when we really want this, if we're using a counter or anything like that, we really want this object to stay locked. So in order to do that, we need to add a few extra things to our setup. We're going to unparent the cube, and what we're going to do is build two extra nodes. We can do that with a create empty group. We create one there and then create two. The first one we're going to call camera constraint. And this is the one we're going to actually be constraining to the camera. I'd rather use constraints instead of parenting, especially to cameras. I'd rather keep the cameras isolated on their own layers. The second one will be a scale compensation. And we'll see how we use this one later on. So we parent the scale compensation to the camera constraint, and now at the moment they're both sitting on world 000. We want this camera constraint to be in exactly the same position as the perspective camera. If we go to this view here on the top view, you can see that the camera is here, and we actually want it to be exactly the same position. A very quick and easy way to do that, we can simple as parent it, and because we inherit all the transforms from the parent, we'll see all these numbers here. Now if we set all these things to 0, we can see that now this node, the camera constraint, gets moved to the parent, which in this case is the camera. If we see it on outliner, if we see that on local mode, we'll see that they're all aligned perfectly with the camera. So once we have it there, we can unparent it, Shift P, and we have it back to the world. And now we get these values here, but that's okay because that's exactly what we wanted. That's the world coordinates. So in order to keep this following the camera, what we'll do is we'll do a parent constraint. So we select the perspective camera, we select the camera constraint, and then if we go to our constraints, we can do parent. Let's go into parents. We do translational, rotation, then we can maintain the offset even though it's exactly one on top of the other. We add that and we got our constraint. Now of course we're not going to see anything so far because the cube is still not parented to our scale compensation. So if we parent this into scale compensation, now what we have right now is exactly the same thing as what we did in the beginning, where we had parented the cube to the camera, because this is just they're just it's a child of these objects, and this is parent constraint. This is going to follow. So if we move that around, this is great. This is what we had before. Now again, if we select the camera and we change the focal length, then we still got our problem. So since now our camera is in exactly the same position, and what the focal length what is doing is really the focal length is a measure of how much the camera and the lens can magnify the scene. So what we need to do is be able to compensate that with our focal length, and we can do that with the camera constraint. Since it's right on top of each other, what we'll have to do is manipulate the scale of Z, and by changing this up and down, in our perspective view, we can see that it's going to be moving back and forth, and this is pretty much exactly what we're doing with the focal length. Now on the top view, you can see that the object is being scaled, and it's being scaled in Z quite a bit, but this is exactly what the distortion of the lens does. In our view, it actually looks the way that we want it to look. So let's go back to 1. So what we'll do now is we have to link our scale Z of the camera constraint to the camera focal length. So we can select we can go to Windows, General Connection Editors. There we go. And on the right panel, we'll select our camera constraint. And on the left panel, we'll select our perspective camera, but we need to get to the focal length. So if I press down, I'll be able to go down to the shape, and I can see the focal length here. So if I reload the left, I can look for my focal length. It's down here, and we can look at our scale. Now you'll see as soon as I select the scale Z, this is going to become really, really small. Now this is why, because the scale suddenly now became 35. So it's really, really far. If we look at the object here, it's going to be somewhere. There it is, and it looks really distorted. So we need to compensate for that, and we really want our number to be 1 back, so that the object appears perfectly in front of us here. So right now we're scaling by 1. So this is why our scale compensation node is here. What we need to do is divide by 35, the 1 over 35, so that we get back to a normalized value of 1. So in our scale set here, if we do 1 over 35, and to do 1 over 35, we can just go to our calculator, and then we go 1 divided by 35, and we get a 0.029. So we'll input that into our values, 0.029, and our cube is back to normal. Now we go back to our perspective, and now we can move it around and stays locked there. And if we select our camera and change our focal length, our cube stays locked. So we can use this for a number of things. Let's go to our counter, and there's our counter. Just did a quick little thing, just hiding and hiding numbers. And now I will change our focal length, the number stays. And this value again is being scaled quite a bit, but because we just seen in our camera view, it actually looks like it's locked in there. And we can use this for a lot of little things, like GUIs for selecting controllers, anything that you actually want just to attach to a camera. That's it for this version of the podcast. I hope you enjoyed it, and see you in the next one. Bye bye.